This pencast will be talking about completing the square to solve quadratic equations. Completing the square is a technique that we use when we can't solve a quadratic equation with factoring. If we tried to solve this quadratic equation, which is x squared minus 4x minus 4 equals 0, by factoring, we see that we cannot do that. So instead we use the technique called completing the square, which is based on making the quadratic into a perfect square trinomial, which, if you remember, is of the form a squared plus 2ab plus b squared equals quantity a plus b quantity squared. So how we do that is the first thing we need to do is make sure that the coefficient of x squared is 1. This will not work if we have another number in front of the x squared, but you can fix that by just dividing the entire expression by that number. So now that we see that the coefficient of x squared is in fact 1, the first thing we need to do is transpose the constant term to the right. And that means we take this negative 4, which is the constant, and move it over to the other side of the equal sign. We can do that by adding 4 to both sides, giving us x squared minus 4x equals 4. Now we need to add a square number to both sides. We do that by adding the square of half of the coefficient of x. So that comes from the fact that we have the middle term, or the linear term, equaling 2ab, and we're trying to find a b squared. So if we divide the linear term by 2 and square it, then we can get the b term. In this case, we have x squared minus 4x plus linear term divided by 2 squared, and we add that to both sides, giving us 4 plus negative 4 over 2 squared. We just need to simplify now, giving us x squared minus 4x plus negative 2 quantity squared equals 4 plus negative 2 quantity squared. X squared minus 4x plus negative 2 quantity squared gives us 4. And same thing over here, which means we have x squared minus 4x plus 4 equals 8. The left-hand side of the equation is now a perfect square, and then we can put that right into our equation, or the formula that we have in the general form. We know that a equals 1x and b equals 2, which is the square root of 4, which means that this becomes x plus 2 quantity squared equals 8. Now we can take the square root of both sides to get rid of that squared term, which gives us x plus 2 equals plus or minus the square root of 8. We can then subtract 2 from both sides to get the x all by itself, which gives us x equals negative 2 plus or minus square root 8. Now we can be done, except for one thing. We need to make sure that the square root of 8 is all the way simplified. We do that by looking at the factors of 8. 8 factors into 2 times 4. 4 factors into 2 times 2. And since we have a pair of 2's, we pull that out of the radical, giving us negative 2 plus or minus 2 square root 2, where this 2 comes from the pair of 2's, and the 2 inside the radical comes from the remaining 2 inside the radical when we solved. Which means for x squared minus 4x minus 4 equals 0, we can factor that into x equals negative 2 plus or minus 2 square root of 2. For x squared minus 7x plus 9, we're going to follow the same method. First, we're checking to make sure that the coefficient of the quadratic term is 1, which it is. Now we need to transpose the constant to the other side of the equal sign, which we do by subtracting 9 from both sides, giving us x squared minus 7x equals negative 9. Now, finding the square term, we take the linear term, the coefficient of the linear term, divide it by 2, square it, and add it to both sides. So we get x squared minus 7x plus negative 7 over 2 quantity squared equals negative 9 plus negative 7 over 2 quantity squared. We know that since the left-hand side is a perfect square, by design, we can stick that right into our formula. We know that a equals 1, positive 1x, and b equals negative 7 halves. So we can stick that into our formula, giving us x minus 7 halves quantity squared. On the right-hand side, we have negative 9 plus negative 7 squared is 49. 2 squared is 4. We can reduce the right-hand side by giving everything a denominator of 4, which gives us negative 9 times 4 plus 49 all over 4, which gives us negative 36 plus 49 over 4, which is 13 over 4. We still have that squared term on the left-hand side, so just like before, we're going to take the square root of both sides, giving us x minus 7 over 2 equals plus or minus the square root of 13 over 4. One of the rules of square roots is that the square root of a fraction is equivalent to the square root of its numerator over the square root of its denominator, which means that we can say equals plus or minus the square root of 13 over the square root of 4. 4 is a perfect square, which means that we can say this equals plus or minus the square root of 13 over 2. And adding 7 halves to both sides gives us x equals 7 over 2 plus or minus the square root of 13 over 2, which is our final answer.